Spring Framework, the most popular framework in Java for application development. Millions of developers use Spring every day to create all kinds of applications. Spring first release in 2003 had a focus on dependency injection, but the framework has grown immensely. The Spring team created a set of modules that support almost everything that a developer needs to create an application. Given so much maturity, it's no wonder that the framework is used in the top tech companies in the world. That's the advantage of a project that has been in constant development and improvement for almost 19 years.
So the idea of this project is to use a setup a bit different than most of the Spring projects. Instead of Maven, we will be using Gradle as our build tool, and instead of Java, you know, Kotlin.
Kotlin is a language made by JetBrains, the same company that creates all the amazing IDEs like IntelliJ IDEA. JetBrains was not happy with Java and other languages in the market and decided to create Kotlin to be an improvement over Java. And when I say improvement, it's because Kotlin was designed to be completely compatible with Java, making it possible to have a shared code base between these two languages, allowing companies to make a gradual migration from Java. Kotlin has been becoming super popular among developers, and according to the Stack Overflow 2020 survey, Kotlin is one of the most loved languages. All this love, it's not for nothing. Kotlin has a lot of features that make the development easier, less variables, and higher failure proof. One of the best functionalities are a native new safer system, extension classes, high order functions, and the async wait version of the language called coroutines. Of course, there are much more features that we will talk about in this video and in future ones. And before we start to create our project, you know that this is my first video on this channel, so please subscribe, hit the like button. This will help me a lot growing the channel and of course create more content for you. So coding time. So to start creating our project, go to start.spring.io and you're gonna see this page. So this is a very useful tool that the Spring team created, and we can do our initial setup for our project. So as you can see, there are a few options here about what's the build tool that we would like to use, Maven or Gradle. For this example, we're gonna use Gradle. Also the language, as you know, we're gonna use Kotlin. There are a few versions here of the Spring that we would like to use. We're gonna use the most stable version, that is 256. The project metadata that you want, you can leave the default values or change for anything else. I will change for Juno coding. And the artifact bank because we're gonna create a sample API that is simulating some payments. You can also choose what the Java version that you want. I'm gonna leave 11 because I still don't have Java 17 installed, but will make no difference for this example. So here in the right column, you can see the dependencies tab. That is basically the libraries that you would like to use in the project. You can see that there are a lot of different libraries you can explore, and we're gonna use just a few of them, and later we're gonna include other ones manually in the project. But for now, let's choose Spring Boot Dev Tools. So this library helps us in the development. It has some very cool features like disabling caching, some automatic reloading. It's very useful for development. Spring Web, that is the library that we're gonna use to create our endpoints in the sample project. Spring JPA and H2 database. So with these two, we will use to save data in our test database. Okay, So having everything set up, we're gonna generate the project and you save in the best place. Unzip the file and open it in your IDE. Wait for the project to finish to index. I will be using IntelliJ IDEA, the community edition, as you can see. You can download for free or use another IDE. Something nice to mention is that if you have the ultimate version of IntelliJ IDEA, the Spring Initializer tool that we just saw is already embedded in the IDE. So you can do all the project creation directly there. First thing, we're gonna take a look in our Gradle file. You can find it in the root of the project folder. This is the file where we can manage our dependencies, and since we use the Spring Initializer for the initial setup, we can see that the tool created this file with our configuration and the selected dependencies. Since we choose to use Kotlin, Spring Initializer already created this configuration file as a Kotlin one. For the people that are not familiar with Gradle, I'm pointing this because it's also possible to write your Gradle files with Groovy. Since we are already using Kotlin, I highly recommend to also use it with Gradle, since there are some advantages over Groovy, like auto-completion for example. Let's take a look at the plugins block. Gradle itself doesn't do a lot by default, but it provides options to us developers to extend and add the new features to our builds. A great example of this is the plugins block, where we have plugins that configure and leave our project ready to use very easily. We can see that we have a few plugins here and most of them are to do an initial setup for Spring. Let's take a look in the Spring Boot plugin page and see how the plugin is described. Spring Boot makes it easy to create standalone production Gradle Spring-based applications that you can just run. That's very important. We take a optionate view of the Spring platform and third-party libraries so you can get started with minimum fuss. Most Spring Boot applications need very little Spring configuration. In other words, easy configuration to start working on your project immediately. All the other plugins do something similar. They prepare and help manage our project dependencies to be configured and integrated in the best way. Below we have the metadata that we choose and the Java version. Maven Central is the repository from where we are downloading our dependencies, and under the dependencies block we can see all the libraries that we have in the project. Later we will return to this file and we're gonna include some extra dependencies. There is another important file that is worth taking a look, and it's our application file. Okay, let's open our application file. In this project on GitHub you can find this file titled as bank application, but this will change depending on what you choose in your metadata. Here we find the most famous functions of all, the main function, where the application starts. We can see that in the main method we have this function run application, indicating to run with bank application class. And in this class we just have a single annotation, a Spring Boot application. The single annotation does a lot for us. Let's take a quick look at how the documentation describes it. Indicates a configuration class that declares one or more bin methods and also triggers out configuration and component scanning. That's very important. This is our convenience annotation that is equivalent to declare configuration, enable out configuration, and component scan. In a minute, we will create our first controller, and something that we'll notice is that we'll not create an instance of the controller. That's because the Spring Boot application annotation is composed of 3 other annotations, and one of them is the component scan. As the name already suggests, component scan will look or scan our project for components, and when it finds, Spring will create and manage this instance for us. Something nice to mention is that for a component to be out-detected, it needs to be in the same package level or below the application class. Components are classes annotated with special annotations that candidates these classes to be out-detected. There are a few different annotations that we can use
for different purposes like component, controller, REST controller, repository, and service. The enable out configuration annotation will also do something similar for the libraries in your project. It will look in our class path, check the libraries that we are using it, and it will load initial configuration for us. You're gonna see this when we set up our database. For now, let's create our first API controller. Create a package called controller and on it a class called transfer controller. Create two methods, new transfer and get all transfers. Let's understand what's happening here. On top of our transfer controller class, we use two annotations, REST controller and request mapping. REST controller, using this annotation, we indicate that the Spring Boot that this class is a web controller. It will receive requests and return response to the callers. Since it's a type of controller, this component, keep in mind this term, it will also be managed by Spring Boot. Request mapping, this indicates what's the signature this web controller will have in the request address after the host address. For example, our two methods endpoint will have the following address, and you can see that in the middle of the path, it's the same /transfers that we indicated in the request mapping. Following the methods, they are relatively simple. New transfer logs a saved message in the console, and his annotation indicates that this is a post request. That's why it's post mapping. And like the controller, it indicates what's the signature for this method with final/new. Get all transfers, it's similar. He turns a hello message to the caller, and similar to the previous method, it indicates the type of the request, in this case a get, that's why get mapping, followed by the signature that is final/all. Get and post are part of the REST specification. If you are not familiar with it, then leave a comment and I will create a new video explaining it more in depth. Now we have everything that we need to do our first test. Go to the main function in the application file and run your application. You should start to see some logs, and Tomcat, our web server, will start and host the application without any problems. Notice in the logs that Tomcat will tell you what port your application is running. Usually it's the 8080. Now we need to test these endpoints. The best way is to use a tool made for that. I personally recommend Postman. It has full support for REST APIs, making it possible to test all the different types of REST endpoints, setting up JSON bodies, headers, authorization tokens, and all you need. Postman also has GraphQL support in case you are fancy. Damn! Okay, I hope that at this point you already installed Postman, so let's do our first testing. So open a new tab on Postman, select get, and type the get all transfers endpoint. Like the example, we are using localhost, that is our local computer. Your port, in my case, is 8080, probably yours it's the same, /transfer/all. If you submit, you're gonna see a hello message in return. So this means that our API is working. Let's do the same for new transfer. Change to type post, the type of our request, the URL. When you submit, you can see that it also worked. You can see the status 200, that means that the request worked. And if we go back to IntelliJ IDEA, we can see in the console that the message saved, it was logged, so everything is working as expected. Next step is to start to prepare our application to receive and save data. Inside controller package, create a new one called model, create two new classes, transaction model and overview transaction model. Into the transaction model class, we're gonna create a few attributes. So let's imagine that to make a transfer to another person, we need to know what's the account identifier, which can be a number or a string depending on the country that you live in. We also need the value and a description that can be optional. When we fetch the list of all transactions, we would like to see a bit more data. Besides all the previous data, we will have two extra fields, the date of the transaction and the transaction identifier. Update your transfer controller with the new models that we created. You can notice that in the new transfer method, we have a new annotation request body. This indicates that the transfer model is part of this request and will deserialize the JSON automatically into our model. Now that we are receiving data through our API, we need to store it in a database. We're gonna use an in-memory database called A2 that we already included in our build Gradle file. Create a new package at the same level as controller called repository. Inside this package, an interface called transfer repository. Let's also create another model package inside the repository, and we'll need a class called transaction DB model. First, let's work on the DB model attributes. Similar to transaction model, we'll have the account identifier, value, and description. In order to save into the database, we need to have a unique identifier, and this identifier will be generated automatically for us. We also gonna use the current date as the transaction date. By constructor, we're gonna receive the attributes that we receive via our API, and in the class body, we will have the extra two attributes, ID and date. We could already initialize the ID with a random UUID, but we will let JPA to do that. We make the set private so we cannot override this value, just read it. The date will always be the current date, so we just initialize with the current one. In this class, we have three new annotations. Entity indicates that this class will be used by JPA to save the data into the database. ID indicates that the field annotated will be the primary key in the database for this entity. Generated value, the name is very self-explanatory. It indicates that this primary key should auto-generate its own value. Now that we have our model, we're gonna create our interface that will do CRUD operations. That is create, read, update, and delete. The way that we're gonna do this is extending our transfer repository with CRUD repository. It's amazing how simple this is and powerful. If you open the CRUD repository interface, it's easy to see what's happening. This interface has all the generic functionalities for CRUD, and all we need is to indicate what type is our model and the primary key. In our case, transaction DB model and UUID. Just indicating the model and the primary keys, Spring will find out what we are using and will inject the full implementation for this interface with the types that we are using. You can take a look at this default implementation. It's a class called Simple JPA Repository. Of course, we are not limited to just these functions. It's also possible to create more complex database operations, but for this video, we're gonna work just with the default implementation. Now that our persistence layer is done, we can save the data that we are receiving from the API. The only thing that we need to do is a small conversion between our models, since the model that we receive in the endpoint is different from the one that we use in the database. Let's create two extension functions to convert these models. Convert to the B model and convert to overview transaction model. First, at transaction DB model, convert the endpoint model into a database one, transaction DB model. And for the overview, something similar, but this time the database model, transaction DB model, into a endpoint one, that is overview transaction model. Now we can convert the data between our endpoints and the database. Let's update our controller to do this calls. Into the constructor, we will include our transfer repository class. Remember, Spring is smart. When Spring sees that we have this dependency in our controller, Spring will inject this implementation created for transaction repository based on the simple JPA repository. You can see that our repository class is using the generic methods of CRUD repository to save and find all the transactions in the database. We also make use of the extension methods that we created to convert the model to the most appropriate one. At this point, our endpoints are all done. Recompile and run the application. Let's create a new transfer request. Remember that now we need to include all the necessary data on Postman to our endpoint to be able to work correctly. Include a JSON body like the example. After submit, everything should work fine. You should receive a status 200, meaning that the request was successful. Now, if you fetch all the data again, you will see the submitted transfer data, including the date and generated ID. Our endpoint is working, but we are still not done. There is a very nice way that H2 database offers us to check the saved data, and that's the H2 console. It's a web admin where you can check the database data and run queries. To enable this console, you need to add the following code in your application properties file inside the resource folder. After added, run the application again and enter in your browser the URL localhost, your port, in my case it's 8080/H2 console. You're gonna see a login window to connect to the database. The only thing you need to change is the JDBC URL. Look into your console logs and search for H2 console available at, like in the example, copy the database URL and press connect. You should set console. Now you can play with your database, you can run SQL queries and see the data that was saved using our APIs. Now we are done, right?
No!
We are good developers, and good developers write tests. Before writing our first test, let's add a new dependency in the dependencies block inside build Gradle. With this dependency, instead of Mockito, we're gonna use Mockey to create mock instances. This library helps us to support Mockey better in the Spring context. Create a new class called Payments Controller Test inside the test folder. Take a moment to take a look at the tests and we will understand what's happening. The general idea of what the tests are doing, it's easy to understand thanks to the Spring testing framework that it's very expressive. Let's take a look in some details. Web MVC test annotation indicates that these tests are testing a MVC component, in this case a REST controller. Mock MVC, it's an entry point that will allow us to communicate with our controller during the test, doing requests and checking the result and the status. Mock bean, we are mocking a fake transfer repository class to simulate different scenarios. We simulate these scenarios always before we perform an action with mock MVC. Mock then resumed from find all and save methods. The first test, we wanna submit the transaction with success. We create a transaction model example. We mock the repository save method return. We perform post. We map this object into a JSON file and we expect a success in the end. The second test, it's similar. We also create a mock transaction DB model. We mock the repository method find all. We perform a get request. We also expect a success in the end with a JSON and we check inside this JSON for the description. We compare the values with the same one as the mock. The third test, it's a bit more simple. We try to do a post request without any body and we can expect that it will fail. So we check for a 400 kind of error in the end. So that's it. Now we are finally done. Thank you very much for watching this video until the end. Please subscribe to the channel, leave a comment with your suggestions for future videos. And of course, you can also find the entire code of this project in my GitHub. I will leave the link below. Thank you very much and see you in the next video.